is, let's take an example, like say on this here, finding. Let me show you how you could use this to figure inverse Laplace, and then we'll move on to the other. So like here, it says find, this means inverse Laplace, okay?
Yeah.
Of e to the minus 4s times 2 over s squared plus 5 over s. Let me use the other s because this is going to confuse it with the 5. So I'm going to use triangle s, okay? S. This is n s squared. Okay, so by looking at this, you can immediately see. So the question is, what's the inverse Laplace of this? By looking at this, you can immediately see that this Laplace transform is shifted because of this e term here, right? So this is like saying the inverse Laplace of e to the minus as, right, times the function f of s, right? Now, what's a in this case? A is the shift. It's 4, just reading it from there. And what's your f of s? It's 2 over s squared. So I'm writing s as a sort of a triangle, okay? So
Yeah.
to distinguish it from the 5,
yeah.
plus 5 over s.
Yeah, the cursive s.
Right? So this is my f of s. So now I know that my inverse Laplace, if I can change the color here, I know that my inverse Laplace of e to the minus as f of s, okay? I'll have you do a question like this because this is important. This is one step where you have to solve the differential equation using Laplace. You'd have to take the inverse. Okay, so so e to the minus. So this is going to be, remember they all connect. This is what we were doing in the last section. This is our u, right? Because you have a shift of t times f. And if you remember, because our shift is a, it's our f of t minus a. Right? Now, what's our f of t? Let me ask you this. It's our inverse Laplace of this here. E to the minus as f of s. Okay? So it's the inverse Laplace of this guy right here, the f of s, 2 over s squared plus 5 over s. You follow?
Yeah.
One of the properties of the Laplace, you can bring the constant out. So, and then this is a linear combination of two different inverse Laplaces. So I could say this is the same thing as 2. Let me write the Laplace like this. Inverse Laplace, 1 over s squared, right? Plus 5 inverse Laplace of 1 over s. And now, if you look at the tables, 1 over s squared is right here. Let's find it. We need, it's right here, okay? 7. So this is going to be, so now let's continue here in green. So f of t equals 2 times, look, this is in the form of the s, yeah? So in this case, n plus 1 equals 2, so n equals 1. So this will be 1 factorial over, right? Because, you know, it's 1 factorial. So this is going to be t to the n here, right? Because this is 1 over s squared. So it's going to be t to the n, and n is 1, so this is just going to be t.
Right.
Okay? 2t, and then plus 5. What's the inverse Laplace of 1 over s? It's 1. So times 1. Okay? So then we get 2t plus 5. Right? So now, what's f of t minus 4? Because remember, our function is shifted by a 4, because a turned out to be 4. So now I can put back my shift into the function. So this is 2, and instead of the t, I replace it with t minus 4. Can you see? So
Yeah.
t minus 4 plus 5. Okay? Which, if you simplify this, you will get f of t minus 4 is equal to t minus 8 plus 5 is minus 3. Okay? So now we can finalize and say that the Laplace transform, or the inverse Laplace, of e to the minus 4s, I promised to write the s as a triangle, times f of s, okay, is equal to what? It's equal to u of 4, because of the shift by 4, times f of t minus 4, right? Which is equal to u of 4 of t, and then f of t minus 4 turned out to be 2t minus 3. So now you know that this is going to be a piecewise function because of that u. So that means the inverse Laplace of e to the minus 4s, or let me right, u to the 4t 2t minus 3 is going to be what? Is going to be 0 if t is in between 0 and 4, because it breaks up at 4.
Yeah.
It's going to be 0, and it's going to be 2t minus 4, right? If t is greater than 4. Sorry, 2t minus 3. If t is greater than 4. Okay, so this is how you find the inverse Laplace of a function. This turned out to be a piecewise function. If you have an e, you know, it turns out to be a piecewise function.
Right.
Usually. Questions on that? We could find out we could do one problem inverse Laplace. How about if you want to try number 13, I guess. Right?